everyone, it's Judy Warner. Welcome to Season 3 of the Ecosystem Podcast. Today we're launching a new series that I'm calling the New AI Design Engineering Revolution. I've met dozens of companies from across the industry that are leaning into AI and LLM technology to help improve your workflow. Today I'm joined by Antonio Becerra of Celis, and he's going to talk about why it's so important to keep you, the designer, in control of the design intent and just use AI to take off the tedious things that take up so much time and take you away from the creative engineering work that you love to do. So remember, go check out the show notes, learn about Celis, and make sure you subscribe on YouTube, or we have a new website at thedoubleecosystem.com. Without further ado, let's jump into our conversation with Antonio Becerra of Celis. Hi, Antonio. So good to see you, my former colleague and friend. It's great to have you on the podcast today.
Hi, Yudi. It's great to be here.
Well, before we get started, for our audience sake, why don't you introduce yourself and then give us a little thumbnail of your background and then give us an overview of Celis.
So, hi, everyone. My name is Antonio Becerra, and I am head of customer success at Celis. I started in the industry of electronics already some years ago with a background of physics. I passed by Altium, where Yuri and me met. And some 3 years ago, I joined the project from Celis and the Celis design platform. And I think today we're going to have a very nice conversation about it.
Well, I definitely wanted to loop you into this conversation about ways that AI and so many platforms are getting stood up using either AI or LLMs for hardware and PCB designers. So I'm really excited to dig in how Celis is doing that and the opportunities it might give for engineers. So in your mind, with that as a backdrop, what are some of the existing challenges and maybe opportunities for hardware designers or PCB layout professionals when it comes to AI and LLMs overall?
Well, that's a great question. I think it is everywhere, everywhere you can look at in the whole development chain, from component finding solutions, verifying those solutions, creating the schematics, validating supply chain information. Everywhere, if you think about it, the whole I was talking with colleagues some time ago. The whole process of creating a PCB is almost a miracle. The engineers need to have in their heads so many things, right? They need to be juggling so much information in the decision making, whether if it is which component to implement, which layer stack to select, where to put the copper tracks, right? um so I think AI is here to be a boost in your capacities more than to um, substitute anyone. I don't think that is going to be the future, but actually, those that are able to harness the power of AI and use it as part of the tools, those are going to be the winners.
Well, I was at PCB West in Silicon Valley a few weeks ago, Antonio, and I heard from Mohammed that you and I used to work with, and Reiner. And then I also talked and had many incredible conversations with companies who are trying to work through, everything from schematic to layout, you know, the whole, they're looking to disrupt workflow, really, and not have to hold all the complexities in their mind, but there is some pushback. And so I want to give a voice to
Absolutely.
those concerns. So as I was doing this and I was posting some things on social, I had really capable, really good engineers come back to me and said, AI can never replace. It is too complex. You have to make judgment calls that are too nuanced for AI or LLMs to ever be able to do it. Some are afraid of losing their jobs.
Mhm.
What do you say?
So
I'm sure you run into these folks, so I'm
yes,
curious, what do you
of
say?
of course, and I would say that I would agree to the point that, I mean, I think AI would be able to make those decisions. I would not want to be the engineer that take that decision and goes with it, right? I think AI is great to provide you with information to help you make that decision. I would not want to be the engineer that tells an AI, hey, I need to create a board with, I don't know, this series of functionalities and specifications. Hit a button, whatever it gives me, I take it to routing. I ask the AI to route it. I take it to production, and then, I mean, I don't want to be responsible for that, because if your job is on the line, I think ownership is key, and that is why using AI to help you in your decision making, right? And can have many shapes. I can tell you a story. I think it was last week. I was checking um, how to work with one specific DC-DC converter. One of these DC converters that has everything inside. It has, filtering and everything for in, for out. And I uploaded the data sheet to ChatGPT and asked, hey, is there anything that I should be adding? Can you check the application? Can you read the information? And he told me, yes, you should add a capacitor for the filtering of the input and a capacitor for the filtering of the output. And when I checked, actually, that was not the case. So it misguided me because it didn't understand it. So at the end of the day, AI is wonderful to help you manage huge loads of information, but the engineer has to be in the driving seat. The engineer has to be the one calling the shots, 100%.
I like this word that a lot of companies it seems to be floating to the surface, which is co-piloting. And I like the idea that you're really unpacking here, that AI is a co-pilot. So the engineer still retains the control and the nuanced judgment calls of the design, but maybe they just speed up their workflow and sort of get an assistant. So then the engineer is still in the loop. So let's talk about Celis. So first of all, what is it? And what are the problems you're trying to solve with this tool? Um, because everybody's coming at this from a different
Yes.
direction.
Yes. So Celis is a startup that was born 5 6 years ago, and it was born actually out of the project from one of the founders to create a board to control some automotive central units. And Tobias Paul found that you can have many solutions to describe very high level what you need to do with software when you talk about the code, and you will get
Mhm.
like packages of code that you can compile together. But when it comes to hardware, you're on your own. You have to read data sheets like there's no tomorrow. Data sheets that I don't know. They can be right hundreds of pages long. So I'm not telling anything new for anyone. Um, and it's very time consuming. And I thought, what if we could have something similar to make the whole, component finding, solution finding, and implementation a much easier and efficient flow. And that is what Celos does. Celos, we have the Celos design platform. You can access it. You can go to app.celos.io and register and access it. It's free for everyone. And what you will find there is a tool that allow engineers to capture the technical requirements and specifications in the form of a block diagram. So I am defining what is it that I need from my board on a very high level. So I have my block diagram, and it is nothing else that a question, right? What I am placing graphically, it's a high level question. Then when I click resolve, the platform goes and tries to find pieces of circuitry, snippets, reuse blocks, application nodes that match my description. Not only the functionality, but specification, interfaces. And now right? Here we have some help of the AI, because I to find matching solutions, I don't need to start reading data sheets from the very beginning, which is a very time consuming process. But now that some solutions have been suggested, very important, the engineer who is on the driving seat goes inside these blocks, checks the solutions. They can interact with another part of our AI. They can interact with Kuot, our AI assistant, to ask, hey, from these solutions, which one has this specification? Or I am searching for a solution between this range, or I want to create this type of, to give suggestions. Now, in in German, there is a sentence that I love and I used a lot, which is Vertrauen ist gut, Kontrolle ist besser, which means trust is good, control is better. So as an engineer, I need to control. So once I am evaluating these solutions that we call Kubos, uh, not to take too long to explain it. A Kubo is a digital data sheet where we're going to find descriptions, specifications, the application of the component, interfaces, so how to connect it. Now I can go inside. I can check all this information. I can check even at this point the data sheet, right? So it doesn't mean that not going to avoid reading data sheets, but I'm going to read them at a much riper stage, rather than needing to read datasheet as a validation, not as a way of filtering solutions, right? Which is way more efficient.
I
And
see.
then I call the shots. I decide which secretary I want to use for this particular block. I can repeat on my whole diagram, and in the end, I'm going to be able to hand over a schematic with all the corresponding footprints, everything connected as I did, to the EDA the tool that I chose. So essentially, we can, before the EDA can shows its power, right, on the layout and everything, we help the engineer get to the point in which they have a prototype with components that fulfill all the technical requirements that they have captured.
So about data sheets, right? How does Celis um, gather the data or organize that data? Because I know I've heard engineers talk about some are in PDF, some are in this format, a Word doc, or this, that, and that it can be challenging to read multiple types of formats. So, in regards to Celis, how is Celis making sure that they vet, and where's the data coming from? How does it vet it? And like you said, the engineer can validate, but how does Celis make those decisions, and where does that data come from, especially if there's dissimilar formats of documents?
Yes, that's a great question, and that is actually something we have dedicated a lot of time to. So first of all, the information comes from the manufacturers we have collaborations with.
Okay.
Essentially, if you think about it, engineers usually don't use the best fitting component for the problems. They use the component that is available and they understand how to implement.
You bet.
So, right, it is then in the best interest of manufacturers to make their solutions as easy to understand and implement and available as possible. And that's right where this collaboration comes in. So on one side, we have the information from manufacturers that that they provide directly to us, so that we can deliver and create these kubos. And on the other side, we also have information from data aggregators. What was the name? Formerly known as IHS Market. I think now it's
Oh,
Accurus.
yes. Accurus. Yeah. Mhm.
Accurate, exactly. So these type of sources, we also use them to make sure that we offer the same quality that manufacturers offer,
Uh-huh.
whether if it is collaborating with manufacturers or with sources of information, as it can be Accurate. And out of that, also AI kicks in, trained AI, to understand that information. Because the key, if you think ChatGPT, as I gave this example of producing some bad answers, which happens, the key here is it depends a lot on what you put in and what you get out, right? If you put things that are
Right.
not very good quality in, you're not going to get very good quality answers. So we have our models that are trained to understand the data in the data sheets. And of course, always there is a human being that is going to be validating a series of key informations to produce the quality that we have on the platform.
So you said early on, Antonio, that it's free. So for our listeners, that's good news. So as you aggregate this data and work with component manufacturers, is that how you're monetizing your product then, is by how you work
Yes.
with partners?
Exactly. That is when we, in our collaborations, we essentially, it is in the best interest of manufacturers that this information is available for them. If you think of our platform can help manufacturers connect with the long tail of all engineers. I would say most manufacturers can connect with what, 10, 20% of their biggest revenue customers.
Right.
So we help them. So our platform for manufacturers works almost as an online intelligent support engineer that is able to
Mm.
provide the advice to engineers so that then they can make the decisions. And for engineers, it is free for them because in the end, what we're doing is offering them the information for them to evaluate, for them to consume, and then implement. So that's essentially in a nutshell how our business model works.
And some have complained that certain platforms will sort of give unfair advantage to particular manufacturers over others. How do you prevent that from being true so you're really giving high quality information and providing the most flexibility for engineers?
Well, here the key actually, like the behind the platform, the key factor for us, and we really do believe it, is that the engineer has to be on the driving seat. And this is reflected, for example, when engineers are creating the projects on the platform. There is a section on the project settings where I can define preferred manufacturers
I see.
or manufacturers that I want to deprioritize. And the same goes for specific manufacturer part numbers. This means that then when I hit resolve, which is making a question, right, shooting this question, the AI is going to take this consideration of the preferences of the developer, and it's going to prioritize Kuos or circuits that match this selection. So that if doesn't matter if we have collaborations with manufacturer A or B, what you get as a engineer is based on your preferences, which is actually, let me say, advantageous for manufacturers because you can get an idea of how it's a benchmarking situation.
Mm.
How do your components work against other from competitors? Um, that is something that you could get some clarity on based on the usage of the service design platform.
Without doing a bunch of time consuming research as a human being. Um, can you define, you've mentioned Kubos and Kubot. Can you tell us define each one of those for us? And then I have a
Yes,
follow-up question.
yes. So Kubos are snippets, pieces of circuitry, reuse blocks. In the end, I explain it very shortly as a digital data sheet. If you take a data sheet, you're going to have a lot of information on how to implement that component. You're going to have application notes. You're going to have characteristics, specifications. You're going to have a description, a name. You're going to have the interfaces that a certain component can have. And that is all that is contained in a Kubo. So you could see it as a reuse block, as a snippet, and which could beg the question, why why then you know have a system with snippets, right? Why do I need the service design platform? The differential factor here is that if I have a huge library of snippets, I need to know what are the factors, what are the specifications, what are the applications of every snippet for my brain to find it, right?
Right.
And that means I need a lot of training, I need a lot of time. Whereas with the platform, I don't need to know what the answer is. I only need to know the question. And then
So
the
you
platform is
it's
going to give it to me.
so it's all being defined by parameters that the engineer set.
Exactly. Exactly.
Love
So
it.
that is the matching. That is the matching criteria, right? That is how the
Okay.
platform searches. Will this Kubo, right? Will this application, this digital data sheet match it or not? And since this is digital, the searching is easier, and then the output is directly in the EDA format, so it's much more efficient.
Okay. And what about Kubot?
Kuot is our an AI assistant, is LLM based, and essentially it's an agent. This is actually a feature that I love because nowadays, and for some years already, we've been talking about this knowledge gap. Very experienced engineers are retiring, and young engineers that are entering the market. It is amazing the amount of engineers that decide to go for coding, for software rather than for hardware, electronic engineers, because it is the hell of a puzzle to develop any PCB, right? So with the help of Kuot, I can make questions. I can to distinguish solutions, to even get suggestions on, hey, I want to develop this IoT development board, this IoT board. I want to take this information, send it via wireless, blah blah. Which, I don't know, DC converter would you recommend me, or which microcontroller, or which protocol of communication would be the best to transfer the type of information? So that this is all information that we have trained our Kuot on, which means that, again, it's not going to make decisions for me, but it's going to provide me very quickly with suggestions that I, as an engineer, can then validate, because it reads the information in the digital data sheets, it reads the information in the Kubos, but it also reads the information in the physical data sheets, in the PDFs from all the components, which means that it can help me a lot with decision making, with separating the wheat from chaff. So it is wonderful. I really like it. And you can speak in different languages with it, which I find amazing.
Oh, that's cool. Well, again, a lot of feedback from engineers are like Chat GPT, right? Using LLMs can do some pretty cool stuff, but doing hardware engineering isn't one of them, right? And it can write pretty good code, but what I hear you saying is that you've taken time to train it and hopefully train a lot of the garbage out, and then use engineer as a verifier. So again,
Exactly.
keep all the judgment, the intuition, all the, like, really creative, interesting work still in the hands of the engineer, which I think everybody wants. They just want the time sucky parts removed. So, how
Absolutely.
do you make sure as you train it that you're validating it, that it's working well?
Well, as with everything, we have a wonderful team of engineers helping validating information, collaborating with the manufacturers to make sure that information is as accurate as possible. I mean, there is always a limit, right, to what you can do. Um, the information on the data sheet is our source of truth, um, and the most important thing for us is to make sure that the system does not produce or produce as little as possible. I would say does not produce, because I haven't seen any
Right.
type of a hallucination in the answers,
Yeah.
right?
Yeah.
So the system will say, "Sorry, I don't have an answer for this,"
Mhm.
rather than tell you, "Sure, go ahead and implement this and that. You'll see, it's gonna be so much fun," right?
Yeah.
That's something that we have been very careful with. And the key is the data set that you train your system on, right? ChatGPT has access to virtually the whole internet, which means that
Right.
if for whatever reason a huge community is saying that you should put, I don't know, ferrite beads to connect grounds, then it's gonna tell you
Yeah.
this is what you have to do always, whatever the application, whatever the board that you're doing is. And so that is something very important for us. That is something that we have put a lot of effort into. And in the end, it's all about supporting the engineer. As we are talking, I do profoundly believe that people developing electronics are in very creative in some sort of way, right? It doesn't mean that you're gonna take gonna start painting the next Van Gogh. But I haven't talked to any engineer that didn't feel so attached to their PCBs, like they were a wonderful piece, right, that they have created. And it's all about that. It's all about supporting them in the best possible way.
Sounds really great. So you mentioned earlier that you can take your circuit layout once you have evaluated, and I'm assuming that it gives you several options, and then you sort of weed through multiple options. You choose it, you modify it till you're happy with it, and then it can integrate with your EDA tool, right, to start doing the layout. What does that work with existing EDA tools, and if so, which ones?
Yes. So we essentially confirm what you've said. Indeed, engineers do check the schematics of the different solutions, and then they can create complete EDA projects in which they will have the schematics, everything connected as they have captured, and the footprints of the corresponding symbols. And then it's for them to go to the EDA tool and start, placing components on the board, layer stack and
Mhm.
whatnot. And for now, as of this recording, we are outputting for Altium, Autodesk Eagle, and KiCAD.
Okay.
But actually, very soon, I don't want to name anything, but very soon, we will also be able to output for other major EDA tools.
Okay. Well, you're gonna have to come back, and we're gonna have to talk about once we turn the corner to 2025, I'm sure you'll have lots of good news. Well, this has been a great conversation, Antonio, and I'll put a pin in the what's next right now since, you can't talk about it. But where before I let you go, where can engineers listening to this recording go to learn more about it or do a demo or, like, what would you recommend?
So you can always go to the LinkedIn page, just search Celis, and then you can contact us. You can also go to celis.io for the homepage of the
Okay.
company, of our solution. And of course, at the celis.io, that's our tool. And well, I would be very happy to see tons of engineers joining, getting to experience it, contacting us, giving us their feedback.
Great. Well, Antonio, thank you so much. It's been great to reconnect with you and hear about all the incredible work you're doing at Celis, and I'm really excited to see, where we're gonna be in the middle of 2025
Thanks a
is
lot. Very
yeah,
exciting
it's
times.
very good time. For our audience, I encourage you, I put the links below that, Antonio mentioned. I'll put those in the show notes for you, but it's free. Like, if I were you, I'd just go do a test drive and play with it
Absolutely.
myself and see if it's a good fit for you. So I'll put all those things below. Antonio, thank you again. I look forward to
Thanks a lot,
to,
Judy.
to watching your ride. For our audience, we'll see you next week. Please go check out the show notes and also subscribe on our new website and to our community where we have lots of free downloads and resources for you at the We'll see you next week. Until then, remember to always stay connected to the ecosystem.